Hi everyone, we'll start. We are going to see how to bring Cassandra to your serious IT department, and I'm going to explain what I mean by that, but let's not be serious right away. My name is Alexander Dejanovski. As you can see, I've some issues with my cat, and yeah, my name is way too long, so just call me Alex. And I hope you enjoy this sweater I put for you today. So you can find me on Twitter, and I'm a senior software engineer and at Chronopost. I've worked there for 15 years. We'll talk about my company next. I do Java, web apps, Python, TIBCO, Android apps, SQL, and just like Neo in the Matrix, I know Kung Fu, so don't piss me off. Chronopost International, we are a specialist in express delivery of envelopes and parcels. As my name doesn't suggest, we're in France. I am French. And we work for both businesses and individuals. We are leaders in express shipments in France. In 2013, we had more than 3,000 employees. 60,000 customer companies, and we deliver more than 100 million parcels per year. And 25% of our income comes from international traffic. So now, please answer me. Do you want to see efficient data models? Yes. Yeah. Awesome lines of code? Yes. I hope so. Crazy low latency graphs? Yes. Yeah, there will be none. You're in the wrong place. Go in the other room. This talk is about what slows down, in my opinion, Cassandra's adoption in European serious companies. Raise your hand if you work in a serious company. Of course. Not this kind of serious, okay? We're not talking about startups. We are talking about rather this. And yes, if you wonder, that's IBM. Seriously, I'm in companies that have an IT history, okay? Mostly companies from the pre-internet and pre-cloud era with legacy systems. And Chronopost was created in 1985, so I consider that we are serious. By essence, those companies usually are not agile, or very partially, or they say they are, but they're not. And they are cautious about, although they like new technologies, but they are cautious with new technologies. And they favor stability, even if they say they favor innovation, okay? You have to keep stability in a complex system like that. You can throw everything away to rewrite your whole infrastructure. So they fear new paradigms, new concepts, and they ask themselves those questions. Will we find people, resources to work on it? Will it work on long term? This is very important for them. Is anyone else serious using it? Because that way we know we can use it too. And are we organized to handle this new concept? When you dig into the NoSQL big data, we hate that term, but that's how it's called. When you dig into this hood, and this is an excerpt from more than 150 different NoSQL databases, you just wonder how you're going to choose one, okay? You have no standard at all. They all claim to be the best, okay? They all have fanboys. We have many Cassandra fanboys in here. And you can find plenty of contradicting benchmarks. And you know those benchmarks are often paid by a company to favor their solution. So the big problem lies in their motivation. They try to do NoSQL or big data because Gartner told them they should, and they fear that they might be missing something huge. That's wrong. That's not the way you should consider this, okay? The right question is, what problems do we have with RDBMS that another data storage system could solve? That's the right question you must ask yourself. Do you need to scale out while reducing costs? Be more fault tolerant, handle multiple data centers, enjoy zero downtime maintenance? You know that's hard. Maintenance, you shut the server down and you have to wait until it comes back. Or do you need to run analytical queries on big data sets? Okay, if not, then stick to your RDBMS and wonder why you came here today. If so, and I think you could benefit, of course, of this, then narrow down this list and pick yours, okay? A bit of common sense and technical knowledge will help you here. So, after thinking a bit and looking at all the solutions, you might come down to a list that looks like this, okay? So we need to filter a bit more. So a few questions you can ask yourselves. Does it handle your use cases at scale? Is there a company that supports it? That's very important for serious companies to have another company to get support from. Is there a strong and active community? And are there big players that use it for critical services? You might get to a shortened list that looks like this, okay? We can put aside Hadoop and Spark, which are analytical tools, not low latency tools, and they both work with HBase and Cassandra. So we'll leave that out for now. A few more questions. How simple and effective is its architecture? Can we use it with current standards and API? Are there some horror stories about it on the internet? That's very important to look for people who went through a terrible nightmare with their solutions. That's what will help you make your choice, not the guys who had big success. And lastly, is it not MongoDB? Seriously, don't go there. Okay. It will work at first, it will do anything, then you start sharding and you lose joins, and then you start scaling up and you lose everything. So don't go there. Okay, that was an easy shot. So now you have it. Cassandra scales linearly. Okay? DataStax provides an enterprise version. The community is actively pushing releases. You can see that we've come from 1.2 to 3.0 that is going to arrive next year. So it's really, we have a huge pace in releases. You have Netflix, Spotify, Apple, eBay, and so on that rely on it. And it's simple and effective as it can be. Only one process to start on each of your nodes to rule them all. It's fully peer-to-peer. It's not even comparable to what you have to do on Mongo or HBase, where you have to set up a Zookeeper cluster, and then a name node, and a data node, and whatever other node you have to set up. So it's simple, okay. And you have CQL. CQL is almost a subset of SQL. So you can use all the knowledge you have on SQL to go to CQL. And lastly, we have a JDBC driver, which might help. Alors, why do we use Cassandra at Chronopost? In December, and I will say it with my best French accent, it's le temps fort. Le temps fort is the time when we get to Christmas, and like the other guy said before me, we have many more parcels, so we double our activity. We have to ship twice more parcels in December. And our infrastructure is always ready for le temps fort, even in August, because we have to be sure that when December comes, the infrastructure handles the load. So we could benefit from some elasticity to reduce our costs. Also, like many of you, we need to manage 2 data centers for disaster recovery, and we deliver parcels fast. We must deliver data as fast as possible. We look really, really dumb when data comes later than the parcel. And we have to handle more than 1 billion events per year. So we started with a proof of concept by porting an existing application from Oracle to Cassandra. That app suffered write latencies, though it was running on a solid hardware, okay? Really big one. And we had up to 13 million inserts a day. And now it performs 5 to 6 times faster on Cassandra. We recently deployed our first original project on Cassandra. We loaded all of our parcel data in it. It handles the load just fine. And it will serve us as a base for shiny new services in 2015. To get that done, we modified the JDBC driver because it was connecting to a single node. And you didn't have node discovery, which makes it quite useless, honestly. So we changed it to make it work first with Cassandra 2 and to add node discovery. So you just give it in the URL a list of nodes that it will connect to discover the topology of the network, of the cluster, and then connect through a round-robin connection pattern. It is available on the official repository on Google Code, so you just have to Google it and you'll get to it. And we are currently modifying it to use the DataStax Java driver underneath and instead of the Thrift API. Keep in mind that Cassandra is made to replace your Oracle or your MySQL or whatever transactional database. It focuses on very low latency queries. It doesn't do MapReduce out of the box, okay? This is not an analytical database, okay? You'll have to use Spark. My choice is Spark. We had Hadoop is not as efficient as Spark, okay? Everybody tells you that, and they are right. But in your company, you'll face resistance by bringing Cassandra into the mix. We have 40 years of normalization and RDBMS behind us. There is a widespread RDBMS experience. IT departments are organized around the RDBMS. And you'll have your own and your colleagues' doubts about leaving the comfort of RDBMS. And unless you've built a full project on Cassandra, you may believe one of the following myths, okay? Myth 1, the normal form suits all query needs. If you have the right model, you can query it any way you want. And a word I cannot tell with a proper accent, there's a corollary to myth 1. RDBMS are at the highest step of data storage evolution, and it is often considered that removing relations, indexes, sum, group bys means regression, okay? And well, Cassandra is often considered as an indexed file system, which was made obsolete a long time ago. Often when you hear about NoSQL, people tell you, yeah, before there were hierarchical databases, and we moved on to normalized databases, so why would we go back to this? The thing is, at scale, rules change. Be my guest and try to query an unindexed field on an Oracle database with more than 15 million rows. And if you add indexes, you will kill your write performance. RDBMS, by essence, are not scalable. They do not fit modern data volume needs. And relationships tend to get inefficient at scale. Myth 2, this one I heard in our company. Cassandra is not ACID, thus we can't use it. This is Aaron Morton, who is making a presentation in the other room. Opinion on myth 2. ACID was designed for that. Begin transaction, read data, show data to user, update data, commit transactions. Okay, that's so 1990. Okay, transactions are not fit for current volumes. So Cassandra is not ACID. Okay, if you know the CAP theorem, you understand that it cannot be. But we have tunable consistency and atomic batches. We have lightweight transactions that Jonathan Ellis showed you this morning. The thing is, you don't need to be ACID most of the time if you're aware of it. And you will build your software knowing that. And one more time, transaction kill performance. When we had issues with RDBMS, RDBAs told us, don't do transactions. It will be faster. Myth 3, Cassandra is not stable or mature enough for production. Apple runs 75,000 Cassandra nodes. Netflix switched from Oracle to Cassandra in version 0.7, and Spotify did the same from Postgres. They are all in productions, and they have all been for years. So Cassandra is totally ready for productions, for your production. Myth 4, we cannot make real functional apps on NoSQL system. I've heard that too in my company. The guys were wondering, can we make real apps with Cassandra? Amazon handles your orders using NoSQL. Spotify manages your music, and Google manages your life using NoSQL. So, of course, we can make whatever app we want. Cassandra is just a distributed and effective way to store your data. You can build whatever app you want on top of it, except a queue, although Comcast built a queue on it. So really, whatever you want. I've heard that too from a DBA. NoSQL system may lose data like that, randomly. So you never know if you're losing data or not. Okay, if you know Cassandra's write pattern, it is flawless. Okay? First, you write on the disk, on the commit log, to secure data, and then you go to memory in the mem table. You cannot lose data. If your server crashes, you lose the memory, and upon restart, the commit log is replayed. You cannot lose data with Cassandra not knowing it, okay? And it's the most efficient use of I/Os that I've seen, really. If you look at the architecture of Cassandra, it's the most effective way to use a hard disk, plain and simple. Okay? If you lose a server, you run a repair, and you get your data back from replicas. The sixth myth is a bit different, and there's a common thinking that you can bulk load quite anything in any big data system and then query it any way you want. Okay? Cassandra does not allows that. Okay? It's not a search engine. It's a highly concurrent, low latency database. It restricts drastically the queries you will be able to make. Okay? Modeling is where the magic happens. Modeling is the way you will allow your users to query data this way. And money won't pop out of Cassandra like this. Get a proper use case to benefit what it offers. Okay. In a company, database is a shared asset. Okay. DBAs dedicated their careers to RDBMS. SQL developers, I think we say SQL developers too. And most Java and app devs use abstraction layers on top of database. So most of them don't even bother thinking what the modeling is, okay? They use a Hibernate or something like that, and they leave DBAs and SQL developers worry about the database. Okay, we could have this repetition of who owns the database in a company today. But Cassandra is disruptive because DBAs should better have Java skills and know how to optimize a JVM and what garbage collection is. SQL developers too, okay? Most of them are used to do bulk load and then insert select. They cannot do that anymore. You don't have stored procedures. To manipulate your data, you'll have to make an actual program. And now app devs need to constantly change the model. Okay, you cannot tell the DBA, here's the data I want to put in, give me back the model, and I will work on it. Because you have query-based modeling where you have one query, one table per query. So you have to rebuild, modify your model as you are building the app. Okay, my recommendations is to acknowledge from the start that resistance to change is necessary and you will face it. Okay? It will filter bad ideas and prevent you from making some wrong choices. And it will force you to work and learn harder and come up with better arguments. Start with your very own projects, okay? Before trying to push Cassandra to others. And don't advise on something you haven't practiced unless you're a consultant. Any consultant in the room? No? Okay. Usually, you don't want others to tell you what technology you should use, so don't do that. Mind your own business. Learn SQL3 modeling, okay? You have plenty of Cassandra Summit's video, especially from Patrick McFadden, which you have seen here. The DataStax website is filled with webinars that will learn you how to model data, okay? And you have Google, of course. Find in your company a high-level sponsor, okay? You'll need a proper infrastructure to start. 3 to 5 nodes. Don't try building, you can work with Cassandra on your laptop for development needs, but if you want to show your company how fast it is, use proper hardware, okay? 3 to 5 nodes, 16 to 32 gigabytes of RAM, and at least 2 HDDs. That's essential. You will separate the write load from the read load. You'll have a bad time if you only put one spinning disk and every I/O goes on it, okay? You can put only one hard disk if it's an SSD. You will need help from your ops team, okay, to build up that infrastructure. You will need time to build or port your project. In our case, our CIO support has been our key to success because people were busy doing other things, real things, serious things. So we needed him to make them help us. You have to understand that Cassandra will be seen as a threat, okay, to some, because it gives more responsibilities and freedom to app devs. Like I said, no more bulk load and insert select. You don't do that, okay? And now you have to redefine how SQL developers will work with Cassandra. That's hard. And it redefines to the skills for a DBA. And another one is that physical is preferred over virtual machines. And all our companies have invested very much in virtualization, and now some are a bit pissed off that when we ask them to make us physical machines. Remember that whatever price, and I'm not talking about money, you pay to bring Cassandra to your IT department is necessary for scalability, fault tolerance, scalability, to have a bottleneckless and cloud-ready architecture, to lower your infrastructure costs, and scalability. And by the way, alive! Here comes the latency graphs. You're happy? Yeah! So, here is a latency graph that compares what we had on Oracle and what we have now on Cassandra. And you can see it's pretty linear on Cassandra, doesn't move that much, while we have really bigger variations on Oracle. And this is our peak usage on the CPUs of our 5-node cluster. So right now, it's way underused, okay? This is the write latencies we have. So we are under 0.3 milliseconds per operations on writes. And read latency is even better, okay? So when people tell you, yeah, Cassandra is good for writes, but not so much for read, that's wrong, okay? A final word. Currently, we have a single 5-node cluster, which is way underused. Our target is about 20 nodes split in 2 data centers for fault tolerance, and maybe a 5 analytical cluster, 5 nodes. The thing is, you can feel the difference with a few gigabytes, okay? You don't have to have petabytes of data to enjoy Cassandra. So it can handle petabytes of data, but you don't need that. You can start with a small project and make it faster with Cassandra than with a traditional RDBMS. Thank you very much. Any questions? Yeah?
In large companies, one of the things the enterprise normally wants is a published data model. How do you fit that in with Cassandra? Have you got the tools to produce a formal data model?
A formal data model?
Yeah, like Irwin, power design, all those things. I guess they're not set up to support Cassandra yet.
I didn't understand, sorry. The last part.
For the relational world,
yeah,
there's a lot of existing tools for people to design the relational model.
Okay, I understand. So no, you do it by hand mostly. You have no relationship. So you can make diagrams like you did before and point out the relations even if you cannot do joins. So you still create tables using a create table command. So you'll find it's relatively easy when you come from a SQL world, SQL, okay? Because it's basically the same way to build a schema. So you can formalize it the way you did before with RDBMS. But there are no tools for that. Not that I know, at least. Yeah. You have to.
So can you shed a bit of light, because that's kind of complicating delivery of the project a bit, and I'd just like to know, to have a realistic view of how complex that is and can that problem be cracked?
Okay, we brought up lots of new statistics using only Cassandra. Okay, before we used to ingest data and every hour aggregate them to calculate our statistics. Now you have counters. Counters is a specific data type in Cassandra that is accessed only through increments or decrements. So you can just create tables with counter fields and then aggregate in real time all the statistics you want to build. And believe me, it's really easy. It's easy as hell. And on our first project, we had problems because each hour we were trying to gather statistics on what happened an hour before. And as the volume grew, it took a longer and longer time, and it was hard to get statistics. So before diving into Spark or Hadoop to do this, try to understand how counters work and how you can benefit of it, because they will give you some time to learn about Spark and other analytical queries. But still, you have to build new tables to respond to the report needs. Okay? You have to do that. Anyway, you will build many more tables to do the same thing than if you were on RDBMS. That's the way it goes. One query, one table. Anyone? It's okay?
That's technical question. But you rather flippantly mentioned the DBA point, and it's something we've came across very relevantly.
Of course.
How did you address that particular debunk the myth, I guess?
Yeah.
How DBAs are scared petrified of this sort of technology because they see it as taking away what's been the other thing they've known for the last 10, 15 years, and they believe it's a move towards a DevOps culture where they won't exist.
Yeah. I think we still need DBAs, of course. The thing is, we have to train them, educate them in understanding what it is. In Cassandra, you will find solutions to problems that relate to RDBMS. They can understand why we do this. You have sharding in RDBMS, and you know why it's hard to put up. So just explain them that they fit in this new architecture. There's a role for them, and teach them why you have to put lots of things away just for the sake of scalability. Okay, so the thing is, they will have to learn about Java, about JVM, about stuff like this. Maybe they don't know Java. So it is the social responsibility of your company to train DBAs and to find them a use in this new era. Yes?
So linked to that question, as you've said, in a mature organisation where you have a lot of existing organisation structure and DBAs and entrenched skill sets and so on, how much emphasis do you think to spend on educating and retraining these people versus just say, well, we'll just show you, we'll just do it, and then you either get it or you don't?
You'll mix both. Indeed.
Yeah.
At first, you are the one who has practiced Cassandra, so you have to show them, okay? Otherwise, your company can send everyone into training, and then they come back with the proper skills. But the thing is, show them why it will solve problems they have today with RDBMS. I mean, DBAs too. And how the architecture will help them get rid of replication problems and inconsistencies between the replicas, because it's all natural in Cassandra. So first show them, and when the company agrees to go into Cassandra, then they will have to do proper training to bring everyone to the right level of knowledge. Yeah?
How long did it take you guys to implement your Cassandra solution?
2 months. The porting, the application, and I did it barely myself. I mean, porting the first project. Bringing up the infrastructures was longer because we had to order machines, and that was what took a long time, because you have to talk to the sales guy, please order a machine, and then you have vacations, stuff like that. So the administrative part was the longer. Bringing Cassandra into the mix was easy because we had JDBC driver, so we had the same APIs to work with it. We had CQL, which is very similar to SQL. So the shift wasn't that big. I just had to rewrite most of the data model. But it comes naturally when you understand, when you are faced with the queries you cannot make, and you understand how you have to build your tables to answer your app needs. But mostly the dev was done. I wasn't full-time on it because I had other things to do on other apps. But that was a 2-month span, really spent on it, one person. So it's not that hard.
Was it just you doing it, or part of it?
I had a colleague that worked a bit on it, but I was most of the time the one building the app. But now for our second project, we have a bigger team to work on it.
Do you find any much impact in the application development team? Do they have to, is there a learning curve significant?
Yeah,
yeah. How they did it?
Yeah. You will find yourself very embarrassed at first when you have to make some queries and cannot, plain and simple. And you might wonder, but how can I build a real app with this system? I cannot use the criteria I used before in my workflows, okay? So there is a learning curve. At first, developments will cost more than with RDBMS. And as you get knowledge, experience, it will be much faster. Okay, so it's time to stop. Thank you very much. I've been asked to tell you to go straight away to the next session, if you know which one. And have a nice evening.